Okay, Bismillahirrahmanirrahim. So this is our today's lecture. We will study speed, travel time, and delay studies, and I will be covering this lecture from directly from this traffic engineering book, so that you guys should also put this habit of reading directly from the book and not just relying on slides as well. So, talking about the title of this lecture, speed, travel time, and delay study. So these three things, these are interdependable. These they are they depend on each other. So let me I will read a little bit from this book and then I will cover it for you guys. So speed, travel time, delay, they all are related measures and commonly used as indicators of performance of traffic facilities. So all relate to a factor that is most directly experienced by motorists. That is, how long does it take to get from A to B? So motorists, they definitely want that they have minimum time consistent with safety. So in highway capacity manual, average travel speed is used as a measure of effectiveness for arterials. Now, if you have an arterial load, so as per the highway capacity manual, for example, arterial load ki misal, that is university road. So for that, for arterial loads, the highway capacity manual specifies the use of average travel speed as a measure of effectiveness, not only for arterials but also for two-lane rural highways and for more extensive facility evaluations. Now, this is an evaluation technique used for arterials and two-lane rural highways where people are moving. But what if you have an intersection and that can be a signal control or a yield control intersection? So for that, the measure of effectiveness is the control delay. What is it? We'll explain it in a while. Whereas freeways use density as a primary measure of effectiveness. Freeways, I had already explained that term to you guys that freeway means that you have a road which has controlled access points, but the difference between motorway and a freeway is that motorway is token toll tax is taken on motors while freeways there is no toll tax. Okay, so in freeways, if you have to study is effectiveness, so you use the density. And what is density? Density actually means that how many number of vehicles are present per meter length of a road. For example, if you take a snapshot, so and if you can count the number of vehicles in 1 kilometer of the road section, so that is your density. So that means that depending upon the type of road, we have different measures for effectiveness, for measuring its effectiveness. Now, book says that the traffic engineer they must understand that how to measure and interpret data on speed, travel time, and delay in ways that yield a basic understanding of the quality of operation on a facility and in ways that directly relate to defined performance criteria. So speed is an important factor in evaluating high accident locations. So when accidents occur, usually when the vehicles are moving at high speed. So that is why speed is an important factor in to evaluate high accident locations, as well as another safety related investigation. But you guys must remember this and must keep this in your mind that poor speeding is not the only cause for accidents. There are also other reasons as well. But you can say that speed is one of the major reasons of accidents. Now, speed is inversely related to travel time. Of course, if speed is high, travel time will be less. For example, if a car A is moving with 40 kilometers per hour speed and car B is moving with 80 kilometers per hour speed, so definitely travel time of car B will be less. The reasons and locations at which speed or travel times would be measured are, however, quite different. Speed measurements are most often taken at a point or a short segment of roadway under conditions of free flow. So if you have conditions of free flow conditions means that where the vehicles experience no obstruction and the drivers they have they have been allowed to just move with whatever speed they can move considering the features of the roadway but without any obstructions. So the intent is to determine the speeds that drivers select. Okay, so if you have a road, for example, ring road, okay, and if for sometime uh, you just allow the through traffic to move. Just all the roundabouts, the intersections, you just stop the traffic there and you just allow the through traffic movement. So now in that case, the drivers they will try to attain free flow speed. So now it will depend upon the drivers that what speed they are selecting. Different drivers will select different speeds. So and remember, free flow speed is unaffected by the existence of congestion. Thus, free flow speed data sudah si un kateshi kana chaka speed chikam drivers will maintain side free when they are not experiencing any congestion. Was congestion we so definitely agi kam speed bani move ke the word they cannot do that because they are experiencing congestion. But if there is no congestion, their drivers come speed server that is the free flow speed. So this information is used to determine general speed trends. Jistakam population become locality that the speed trends are to help determine reasonable speed limits. Now once you know about the speed trends, ठीक शो? So then you can select a reasonable speed limit and speed limit depends upon also the road and geometrical features as well, curves and to assess safety. Such studies are referred to as sport speed studies because the focus is on a designated sport or location on a facility. So why it's called a sport speed study? Because you are studying the speed of traffic at a particular spot or location on that road facility. And remember that it is usually done where you have free flow conditions. Okay. The coming towards travel time, so it must be measured over a distance. Although sport speeds can indeed be measured in terms of travel time over a short measured distance, most travel time measurements are made over a significant length of facility. Such studies are generally done during times of congestion specifically to measure or quantify the extent and cause of congestion. So the next thing that you want to measure is the travel time. For example, somebody wants to travel from KTH hospital to Peshawar Sadar. So how much time is required to move from KTH to Sadar Peshawar? So in order to answer this question, you must conduct a travel time study. Now you can also say that you can also use the spot speed data because speed is equal to distance divided by time. So if you have the spot speed and if you have the distance from KTH to Peshawar Sadar, you can easily find the time, which is the travel time. S is equal to, sorry, V is equal to S by T. Okay, that formula from FSC, if you remember. But they are saying that you will have to find travel time and you have to conduct this travel time study over a significant length of facility. This is because that over a particular section of a road, what happens is that the traffic conditions they are not uniform. They are changing. Similarly, there are a number of drivers and their physiological, psychological health, mental health. It it is different and also it also depends upon the age. Third term that we are coming toward is now delay. So delay is a portion of total travel time. So it is that portion of travel time that is particularly identifiable and unusually annoying to the motorist. So delay is that portion of travel time which is annoying to the motorist. Why? For example, delay along an arterial might include stop time due to signals. उस free flow conditions में there are signals on an arterial road. बार बार the drivers उधर पर signal पाए. So they feel annoyed. ठीक शो? So this is what you mean by delay. There can also be other reasons of delay such as mid-block obstructions या other kinds of congestion कसे accident شيء या Bakasa Gadi accident to Shi Agipo Makka Road Waladi and causing delay to the driver. So delay is a portion of travel time because kata congestion the waji walade or the movement nishi pole. So this delay is becoming part of your travel time. So normal हालात की चीज मतलब दशपे for example 12 बजे तो KTH ने सब पिशाव सा there is almost no vehicle. No धक्का क्या कल जिते the व्रजे like माजिगर time की 3-4 बजो की so delay is there. Sure. And the delay due to when you move from KTH to Peshawar Sadar at 2 p.m. to 5 6 p.m. around. So that is due to high volume of traffic, which is also a type of congestion. So at signalized and stop control intersections, so delay takes on more importance because travel time is difficult to define for a point location. Because you cannot define travel time for a point location, it is always between two separate points, and the 2 points must be separated by a you can say here, but they have said that it must be measured over a significant length of a facility. Unfortunately, delayed intersection, specifically signalized intersection, has many different definitions, and the traffic engineer must be careful to use measurements and criteria that relates to the same definition. So now we are coming towards the definition of delay, which is applicable at signalized intersection. So these are the different definitions which are applied to delay at a signalized intersection. So the first is stop time delay. So it is the time a vehicle spends stopped. The vehicle is stopped and he is waiting for the green signal so that he can start movement. So this is known as a stop time delay. So masad lata udrole intersection. The second one is the approach delay. So it adds the delay due to deceleration and acceleration from a stop to stop time delay. For example, approach delay means if you are approaching towards a signalized intersection and if red light is on, so he will be deaccelerating and he will come to stop. So the time lost in this plus when the signal turns to green and he has to start movement, so the time lost while he is accelerating his vehicle. So that is the approach delay. The third definition is time in queue delay. So the time between a vehicle joining the end of a queue at a signalized or stopped control intersection. So you have a signalized or stopped control intersection. So the time between a vehicle joining the end of a queue, if the red light is on, no qatar bajod shevi. Queue is to kya qatar. It's here Urdu word dekho. देखो, and the time it crosses the stop line to proceed through the intersection. So come time show the time between he joins the queue and the final time is when he crosses the stop point to proceed through the intersection. So this is known as time in queue delay. The last one is the control delay. So the total delay at an intersection caused by a control device. So you are standing at an intersection and the delay caused by a control device. It can be either a signal or a stop sign, including both time in queue, the time that you spend in the queue, plus delays due to acceleration and deceleration. So I think the control delay, the last one definition, it is much more realistic as there is delay due to acceleration, deceleration. Also, the vehicle spends times in queue. When it joins the end of the queue, Roro Gadi Ravani, and Akhirkar it crosses the stop sign and moves through the intersection. So this control delay definition, this term and its definition, it was introduced in the Highway Capacity Manual in 1985, and it is used as a measure of effectiveness for signalized and stop control intersection. So this definition they have adopted it for measuring the effectiveness of a signalized intersection. For example, you have timed signals at an intersection. So how will you know that the signal timing, the number of lanes, and the traffic volume, it is effective? It's an effective system. That by effective I mean that you are not making the vehicle stop for a longer time. You are not making somebody stay for a longer time. So this is what you mean by effectiveness. So travel time delay is the difference between the actual travel time, that is actual travel time traversing a section of highway, and the driver's expected or desired travel time. So there are actually two travel times. Travel time one is actual and the one is expected. So actual is distance divided by actual travel time is actually distance divided by speed, and expected is that in how much time you can reach there, because normally the road is not empty, it is full of vehicles. So of course there will be congestion, sometimes an accident, so it can increase or decrease your travel time. Okay, now because speeds are generally studied at points under condition of free flow and travel time and delay are generally studied along section of roadway under congested condition. This is important. Speeds you studied under free flow conditions because you want to see how much the drivers can attain speed and how much they want to move at how much speed they want to move. And travel time and delays they are usually studied along section of road under congested conditions. So now we will come towards sports speed studies. So sports speed study means the purpose is to document the distribution of vehicle speed as they pass a point or short segment of the roadway. Because the traffic engineer is interested in conducting spot speed studies under condition of free flow. That is, observed speeds are not impeded by volume and density condition. You are not making the drivers exposed to congestion. You are allowing them to make their own decision to move at their own speed. So they are not generally not conducted when volume in are in excess of 751,000 vehicle per hour per lane. That means that if, for example, if I take the higher level, if the number of vehicle is greater than 1000 per hour per lane, यानी कि यो लेन ना प्रयोग घंटा के हजार न ज्यादा vehicle so then you should not conduct the sport speed study because the 1000 vehicles per hour per lane na volume से बाकी so then congested condition is there, traffic density is increasing, and the conditions are not that of free flow. Okay, there are some definitions of interest, and these are average or time mean speed. So the average speed of all vehicle passing the study location during the period study. For example, you are conducting the spot speed study, and your study time is let's say 1 hour, and during this 1 hour, 100 vehicles passed. Okay, so the speed of these 100 vehicles, so by 50 kilometer per hour, so 60, so 62, 6, so 65. So if you take the average of all these 100 vehicles and divided by their number 100, so this will be the average or time mean speed. So average singa cricket matches ki average score. The next term is the standard deviation. Those who have studied the probability and statistic course, they will be much more um, familiar with these terms. Standard deviation. So, in simplistic terms, the standard deviation of speed is the average difference between the observed speed and the time mean speed during the period of study. So, standard deviation means that J, uh, what speed, what is the speed that is deviating from the mean speed? For example, if the average speed is like 60 kilometers per hour and standard deviation is 10 kilometers per hour, so that means that up to plus one standard deviation, the vehicles that are deviating from the average speed is 10 kilometers per hour. So 70 kilometers per hour, 60 is the average speed. The next term is the 85th percentile speed. So 85th percentile speed is the speed below which 85% of the vehicles travel. For example, you have uh, in your survey you had 100 vehicles observed during 1 hour of your study. Okay, now 85th percentile speed is that speed. For example, the 85th percentile speed after the analysis came out to be 55 kilometers per hour. So that means that 85% of the vehicles that passed during the study period, they had a speed of 55 kilometers per hour or less than that. The next term is the median. Median is also a term like average, median, and mode. So median means the speed that equally divides the distribution of spot speed. So median is that value which divides your study speeds. For example, you observed 100 vehicles. The 100 vehicles had 100 different speed values. So median will be that value from which 50% of the observed speeds are higher and 50% of the observed speeds are lower. So it is splitting that range into two halves. And pace is that 10 mile per hour increment. For example, or you can also say in kilometer per hour. So it is that increment of speed in which the greatest number of vehicles are observed. For example, from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 50 to 60. So what is that interval during which highest number of vehicles are being observed to have speed? We will solve a simple problem on this so you'll understand that. So these are the different uses of sports speed data. You can read it. It's very simple. I will not go into its detail. Now, this is the analysis that you can conduct, but this is the old form which you can conduct this data. Nowadays, CCTV cameras and automatic pneumatic road tubes, these types of automatic devices are used which measure the speed and the volume of traffic. So let's say we conducted a study and we got this data. So if you the different vehicles that you observed was the observed frequency in group. So you observed a total number of 283 vehicles. You observed a total number of 283 vehicles and you divided their speed group. For example, from 32 miles per hour to 34 miles per hour, the number of drivers that were moving with this speed are zero. For example, in your scenario, from 34 mile per hour to 36 mile per hour, the number of people that were moving within this range were 5. So similarly, from 62 to 64 mile per hour, the number of people that were driving at this speed range were 0. So this middle speed column means that 32 plus 34 divided by 233. This middle speed represents the average of this lower limit and upper limit. This is the observed frequency. This data you will be getting from the field study. This is the percentage frequency in group. Percentage frequency means that observed frequency divided by the total. So 0 divided by 283 is 0%. Then 5 divided by 283 is 1.8%. This is the cumulative frequency column in which 0 is equal to 0. Then this 1.8 is equal to 1.8 plus 0. 3.5 came from by adding 1.8 plus 1.8. Then the next 6% came from when you add 2.5 with 3.5 to 6. This is similar to the gradation curve of coarse aggregate or fine aggregate that you must have conducted this experiment during your bachelor's course. The second last column is the product of n times s star star. So n is the observed frequency in group and s star is this one. Okay, n is the observed frequency in group and s is the, where is this? Yes, this middle speed. Okay, and the second last column is the ns2 star star. That is, if you multiply this n observed frequency multiply by the square of speed. Okay, so 0 multiplied by 33 square. So add this fourth number column, just add it, add this one, this sum must be equal to 100%, just as the case of coarse aggregate fine aggregate gradation curve. Add ns column and ns square column as well. So now if you want to find the different statistics like the average, median, 85th percentile speed, 15th percentile speed, so let us see where they have solved it. Okay, this is the plotting of this curve, that the different speed values versus the observed frequency. You can obtain this curve and you can plot this, you can get this curve in Excel if you plot the speeds, this middle speed, this third column on x-axis and this percent frequency in group on y-axis. Similarly, the second figure you can also plot it in Excel if you can plot the middle speed on x-axis and the cumulative frequency on y-axis. So if you can plot these columns, you can get these two curves. This is a cumulative frequency curve. This is ordinary frequency curve. So this data represents that it is normally distributed. and the average will be if you can add all the speeds divided by the number of observed vehicles. Okay, mode according to statistic is that value which is repeated the highest number of times. So in this case, you can see that 49.2 mile per hour speed has the highest frequency. Frequency means it is repeated larger number of times as compared to other values. So its mode is 49.2, and pace means the that interval of speed, that 10 mile per hour speed range over which you are observing a large number of vehicles. So here you can see that 43.5 to 53.5 you are experiencing the larger number of vehicles. So that means this is your pace, and it shows you in reality that majority of the vehicles that is moving along the study route, they are moving with a speed having range from 43 to 53 miles per hour. Similarly, you can also find the median from this cumulative frequency curve, since we already described median as that value of speed which divides the curve into two halves. That is, 48 mile per hour is that speed below which 50% of the vehicle has lower speed and 50% of the vehicle has higher speed. Similarly, from the cumulative frequency curve, you can also calculate the 85th percentile speed. So, doing that, this is 85. So, if you start from this 85 digit, you intersect with this curve and then you move down. So, that tells us that the 85th percentile speed will be around, you can say, 52 and 56, so it's a 4, so it will be around 54 mile per hour. So 54 mile per hour is that speed below which 85% of the vehicle are moving at this speed or at a speed less than this. So this is the formula for finding the average speeds. NS and capital N, these are all defined in the table, the above page. This is the average speed, the median and the mode. We can very much easily find it from the graph. This is the value of standard deviation. This is the formula for it. You can also calculate the standard deviation if you can insert this data in Excel sheet. So Excel will directly calculate it for you. So 4.96 mile per hour is the standard deviation, and similarly these are the 85th percentile speed and the 15th percentile speeds. So 15th percentile speed is 43.7. That means 85th percentile speed is 52.7. That means 85% of the vehicle are either moving at 52.7 mile per hour or less than it. And 15th percentile speed is that speed at which 15% of the vehicle are the 85% can speed to roughly estimate the standard deviation distribution. Okay. Okay, so I think this is the data that you can find from it and the interpretation of these different terms. Here, if I can show it you from the figure, that so remember that the 50th percentile speed, 85th percentile speed, and 15th percentile speed, you can calculate it from the cumulative frequency curve. The 85th percentile speed you can also interpret it like 52.7 mile per hour. So you can say that 85% of the vehicle are moving at this speed or less than it, or 15% of the vehicle are moving at speed higher than 52.7 mile per hour. Similarly, you can also interpret P15 as well. Okay, normal distribution in the analysis of sports speed data, so I am not covering this. If somebody is interested, so he can do that. And if any student had taken the probability statistic course, so then it will be very much easier for him. Actually, the purpose of conducting the statistic analysis of the speed data, its purpose is that at how much its purpose is to find the confidence level. Confidence level means that, for example, if you can say that I am saying that this speed will occur and my confidence interval is 95%. So that means that 95% of the time the speed will be that much. Okay, only 5% of the time it will be less than that or greater than that. So statistical analysis is usually used for that. Statistical analysis is used to answer questions like that if you are stating that this much speed will be observed by the vehicles based on some data. So then people will ask you the question that what's your confidence interval? On what basis are you saying this? So then you can say that I have conducted statistical analysis on this data and I am saying this with 99% confidence level or 95% confidence level. So this is what it means and you can give it a read for proper understanding it. The next one is the travel time studies. So travel time studies involve significant lengths of a facility or group of facilities forming a route. Information on the travel time between key points within the study area is sought and is used to identify those segments in need of improvement. So um, what is the purpose behind conducting travel time studies? So its purpose is to identify problem locations on facilities by virtue of high travel times and or delay, to measure arterial level of service, to provide necessary input to traffic assignment model, to provide travel time data for economic evaluation. These are the different purposes. You can read it and these are very much simple. My aim in this lecture is to introduce you with these techniques that how can you conduct them. So the field study techniques that you can use to find the travel time is because significant length of roadway is involved for calculating the travel time studies, so it is difficult to remotely observe vehicle as they progress through the study section. So most common technique is to involve driving test car through a study section. For example, uh, you assign some cars to some drivers and then you tell them to start movement from this location to that location. Okay, so the observer who is driving that car, who is sitting there, he is equipped with the field sheet predefining the intermediate point for which travel time is desired. The observer uses a stopwatch that is started when the test vehicle enters the study section and records the elapsed time at each intermediate point and when the end of study section is reached. Okay, so the person who is sitting in that car, who is driving it, and whose task is to collect data, so he's provided with a sheet, and this is the most common and old technique. So he notices the locations where he is facing congestion, where there are problems. He also has a stopwatch where he is noting the time when he travels from one particular section of a roadway to the other. Now, using this technique, so there are different test car drivers and they are instructed to use one of the three driving strategies. So the first one strategy is the floating car technique. So in floating car technique, the driver has been instructed to just move with the traffic. And by saying that, I mean that the he has been instructed that if five vehicles overtake him, he must also overtake five vehicles. If two vehicles overtake him, he must also overtake two vehicles. And this allows and this ensures the vehicle's relative position in the traffic stream, it remains unchanged because he is moving along with that. He is in a condition of floating. So the test car approximates the behavior of an average vehicle in the traffic streams. So the second one is the maximum car technique. So in this technique, the driver is asked to drive as fast and as safely as practical in the traffic stream. So he must consider the traffic stream conditions and he must drive as fast as possible, keeping his safety. This is the maximum car technique. And the average car technique means that the driver is instructed to drive at a speed which is almost the average speed of other cars who are moving at the same section at the same time. Ce cum speed să nu gadi ravandi bas makashan tamba. Now there are some comments on these techniques. So the floating car or Chikam average car techniques they result in estimates of average travel time through the section. Of course, if he is simulating the behavior of other vehicles who are also moving at the same time at that section, so you can get the average travel time. The floating car technique is generally applied on only two-lane highway. If you have a two-lane highway, so you should use the floating car technique because passing is rare and the number of passing can be counted and balanced relatively easy. So if you have two lanes, so if two vehicles overtake him from the other lane, he can also overtake the other two vehicles from the other side. So it is easy to track note of it. But if you have like 3 or 4 lanes, so then it will be very much difficult for the driver to drive as well as keep count of the number of vehicles that are overtaking him or the number of vehicles that he is overpassing. Okay, so floating car technique, you will have to use it for 2 lane highways, or you can also say that in highways where the number of lanes are small, usually 1 or 2, so that he can keep track of it and there is less strain on the driver. So if you have a multi-lane freeway, so then you cannot use the floating car technique, and danger situation can arise because he would either be driving the car or he would either be counting the number of vehicles that are overtaking him on a number of lanes. So in that case, it will be difficult for him to keep up with the number of vehicles that have passed it. So in that case, you use the average car technique. So floating car technique for 1 or 2 lanes and average car technique for multi-lane freeways. So as a result of that, there is less stress applied to the driver. And the maximum car technique, it does not result in measurement of average condition because it will not be representing the average condition because they hold 3 speeds around it. And the rest of the vehicle become actual conditions they are simulate key, so it is not giving us the true data. So rather the measured travel time represent the lower range of the distribution of travel time. So travel times are more indicative of the 15 percentile speed than an average. So speeds computed from this travel time are approximately indicative of the 15 percentile speed. So uh, it is important, therefore, that all test car runs in a given study follow the same driving strategy. Okay, now this point is important that the maximum driving strategy it is not recommendable, not practical because it is only representing a very small sample of a very small number of vehicles because there are only you can say 2 to 5% of the vehicles at a particular point on a road that are moving with the maximum speed. Most of the drivers they just flow, they are just moving with the flow of vehicles. Kadi नहीं ठीक so so they have also here discussed about another technique where observers are standing at the side of the road at different sections and they are noting the time they are noting the time when that particular vehicle crosses that section by noting their number plates, and then the other person also notes the time when the same number plate vehicle crosses that section too. But again they are saying that it is difficult for them because to note down the number plate of each and every vehicle. Here they have also calculated the probability that if the probability that a person will be able to see the number plate and read it accurately if it's zero point 0.5, like it he has a 50% chance of noting it down correctly. So if at section 1 the probability is zero point 0.5 and at section 2 the probability is also zero point 0.5, so then the probability that the same car will be spotted at the two section it will be only 25%. So that chance is very reduced, so this technique is not that much used. Okay, so there is a lot of detail in this chapter but I'm just going through the important information, the rest you can study. Okay, now coming towards the most important delay study, which is the intersection delay study. So, some types of delay are measured as part of travel time study by noting the location and duration of stopping periods during a test run. So, as we said previously, that the concept of control delay was introduced in 1985 or 1987 by the Highway Capacity Manual, and they have also given us a methodology for finding this control delay. So, let us talk about that. Okay, first of all, the methodology that is given by the Highway Capacity Manual, this it is for the following condition. That is, this method is intended for undersaturated flow condition and where for case where the maximum Q is about. For example, if the red light is on, so the maximum Q is about 20 to 25 liters, not greater than that. Okay, it is undersaturated flow condition. The method does not directly measure acceleration, deceleration delay. Chikam acceleration, the acceleration the वजह delay की this method is not giving you any equation, any method for calculating that. Rather, it is giving you just an adjustment factor. And method also gives us an adjustment to correct for the errors that are likely to occur in the sampling process नीचे कल the field के वाला data collect के and you might encounter such error ताना उशी. So it also provides you a factor in order to take care of that. And the observers must make an estimate of free flow speed before beginning a detailed survey. So before beginning detailed survey or survey के वजह से note करी, it will come in the coming pages. The observer must make an estimate of free flow speed. Chikam start the intersection देखा ना, तो जल्दी चikam free flow speed दे आगे तासो find करी. One way is that drive a vehicle through this intersection during periods when the light is green and there are no queues. So मतलब that the intersection cross के light is green, there is no other vehicle. So the speed in this condition that you are attaining, that is the free flow speed. Yeah, by measuring the approach speed at a position where they are unaffected by the signal. Chikam signal na lag lose to distance bani chikam gadi the intersection taraf tarawani, so you can also take that speed. Okay. Now here they have this method asks us to have two observers. Two observer must be noting down the data. So I will come towards, for example, this is a sample data for signalized intersection delay study according to highway capacity manual method. For example, you are before starting this survey, you found the free flow speed which was 35 miles per hour. Okay, you started your survey at around 5 p.m. and this is the cycle number one. Remember the definition of cycle from our previous lectures. So at 5 p.m. you started your survey. This is the cycle number one. So at 0 second, that is 5 p.m. plus 0 second. ला बिल्कुल exact 5 बजी दिलायो second में दौड़ दिले. The number of vehicles that were standing were 4 in the queue. ठीक शो तासर signalized intersection ने गाड़ी queue की वलार दी because the red light दा वजह. ठीक शो after 20 seconds यानी कि 5 बज के 20 सेकंड बानी the number of vehicles in the queue are 7 and then 5 बज के 40 सेकंड बानी the number of vehicles in the queue are 5. Why it got reduced from 7 to 5? Because the दौरान light home green की गई. So light green की गई, some of the vehicles will be moving out from the intersection तासर वो queue कमी की. Then 5 बज के 1 मिनट 0 seconds बानी you had the number of vehicles in the queue were 6. Again after 20 seconds the same number of vehicles are standing there. Zaka Chishan tarafna yo gaadi hum join nako. After 40 seconds, yo gaadi leave ko because only 20 seconds have elapsed, so the time is being taken by other vehicles to start accelerating and move. Also, you must remember that vehicles are also joining the queue from the rear end. ठीक शो कहना गाड़ी को intersection तरफ तरह रवान दी तन्नु का गाड़ी intersection cross कई. So crossing as well हो शा तरफ न हम दूर गाड़ी intersection side कर रवान. So you conducted this survey from 5 p.m. up to uh, 5:10 p.m. because this is the last interval 5 बज के 9 मिनट. So 0 second 5 बज के 9 मिनट 20 second 5 बज के 9 मिनट 40 second and then सिंगल शो 5 बज के 10 मिनट शो. ठीक शो. So the total number of vehicles that arrived at this intersection during this study period is 132. Just add these vehicles 40, 50 and 42. Okay, this is BT and we stop. We will now discuss this. So now the highway capacity manual has given us this formula which is given by equation 1015 TQ where Q is the average time in queue, that is how much second a particular vehicle spends while standing in the queue. ठीक शो जो particular vehicle सुमरा seconds पर queue की वाला है. So that is equal to IS, that is the time interval between time in queue counts. Here they are calculating this. So IS is 20 second. Where is this 20 coming from? Here it is coming from this one. Because you are noting the number of vehicles in queue after every 20-second interval. So IS is equal to 20. VIQ, that is the total number of vehicles that arrived at this intersection during the study period aga 132 di. How did we find this? We summed all the number of vehicles that arrived at that intersection during the study period, and VT is total number of vehicles arriving during the study period. So that is 120 and this number is given to us. So that means 19.8 seconds per vehicle. That is on average a particular vehicle spends about 19.8 seconds in the queue. The second thing is the VSLC, and it is defined here. That is the number of vehicles stopping per lane per cycle. यानी कि how many number of vehicles are stopping in one lane per cycle. यो cycle की सुम्र गाड़ी per lane उतरी. ठीक है. V stop is the total count of stopping vehicles. This is also given to us. NC is number of cycles included in the survey, and NL is the number of lane in the survey lane group. So here we are calculating the VSLC. So the 10 cycles were surveyed. Where this number is coming from? 10 cycles from 5 p.m. to 5:10 p.m. Here you can see 5:09, so 0 second, 20 second, 40 seconds. So you are going up to 10 p.m. So you are observing total number of cycles equal to 10. So this is the total number of cycles. Okay. So here this 10 is coming from, and 2 is the number of lane in the survey group. Where is this 2 coming from? Here is the statement of the problem, that table 10.7 shows a facsimile of a field sheet summarizing the data for a survey on a signalized intersection approach. The approach has 2 lanes. So here they are specifying us the number of lanes. And the signal cycle length is 60 seconds. Remember the definition of signal cycle length. That is, it is contains the amount for the red light, green light, and the transition period, that is the amber light as well. Type cycles are surveyed. So putting all these information, these equations, you will get that is on average 3.75 vehicles are standing per lane per cycle length. The next term is the FVS, which is the fraction of vehicles stopping other variables as previously defined. So FVS means that what fraction of vehicles are being stopped. That is, V stop is the total count of stopping vehicle. That is the number of vehicles that are being stopped. And VT is the total number of vehicles arriving. यानी कि चुसुम्रा गाड़ी तब intersection वन stop की divided by the number of vehicles arriving. चुसुम्रा vehicles arrive की नु सब move की सब stop की signal दवज. So FES is actually it's like a percentage. J the number of the marks that you obtained your metric exam divided by the total number of marks. So you can get it like that. And equation 1018, it tells us about the total control delay. So one, we find the average time in queue, that how much seconds a particular vehicle spends in the queue. So that is represented by TQ, and this T represents the total control delay. This is the term that we are interested in. This is the term for which the highway capacity manual has devised this methodology. So the total control delay, which includes the total delay due to staying in the queue plus time spent in acceleration plus deceleration. That is the difference between TQ and T. So it is equal to TQ, yani ke the average time spent by the vehicle in queue plus FVS times CF. So FVS is the fraction of vehicle stopping, and CF you can get it from this table 10.6. This CF actually depends upon the free flow speed and vehicle stopping per lane per cycle. Okay, so you will get this value from this table 10.6. Okay, so 75 vehicles are being stopped and 120 vehicles are arriving. So the percentage is about 62.5. And D is total, the control delay is equal to 19.8 TQ plus 0.625, which is the FVS times 5. And 5 they have obtained it from this table 10.6. Here the free flow speed was 35 miles per hour. So 35 miles per hour is less than 37. So here you will come this one. And the vehicle VSLC, you will get it from this one. VSLC is 3.75 vehicles. So 3.75 is less than 7. So the value of CF is 5. So now D, which is the control delay, so it came about 22.97. Okay, let us now compare the value of D, which is almost 23 seconds per vehicle, and TQ, which is almost 19.8 seconds. So this D value is almost, if you take this as 20 and if you take this as 23, so this D is greater than TQ by about 3 seconds. So this 3-second delay is due to the time spent or lost due to acceleration and deceleration effect. Okay, so this was all about our today's lecture. I will advise you guys to solve this problem 10-3 of the exercise so that you can have some practice over it. If you have any question in this lecture, please ask me in WhatsApp group.